How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be focusing on EIGRP scalability and why you should deploy EIGRP in a specific fashion. So typically speaking, and the way that we have our environment built out right now is after we migrated from RIP version 2 over here in the upper right hand corner to EIGRP, we had end-to-end reachability through a single autonomous system that stretched from the HQ location over the DMVPN tunnel that we stood up on 58 and then R21 and 22, and then was able to get reachability into the switched environment behind over here in the medium site. So that works well for the most part, but there is the potential for issues that could arise. And one of the things that I am a big proponent on is whenever I'm scaling EIGRP from real world experience is I try to optimize it whenever I can. So I like OSPF because I'm able to break up blocks of routers into different areas based off of their design. So typically speaking, when we get more into OSPF, what I would do is this would be area 0, then this would be its own area, this would be its own area, and each one of these would be its own area. And the idea would be if there's an issue over here, it only affects what's over here, right? Remember, if you haven't gotten to OSPF yet, OSPF doesn't do an SPF run for type 3 LSAs. So if you've got, area 0 here, then you have this interface right here ties back over to here's area 10, for example, then you're going to run SPF for type 1 and type 2 LSAs, the router and the network summary, but you're not going to run SPF on type 3 LSAs. So they're just a notification from one area to the other that, hey, if you want to reach a specific LSA, then point to your ABR and your ABR will get you there. The ABR's job is to do the calculation for you. So with the EIGRP, we don't really have that functionality. So let me go ahead and draw this out real quick so you guys can see what I'm talking about. So what I'll draw a rectangle, and I'm feeling green. So we're doing EIGRP is running over here, right? We have EIGRP running in not necessarily specifically to these boxes, but it is running over here, and it's running over here, and then we have EIGRP running basically from here to here, and from here to there. So everything in green is running EIGRP. So what that means is if anything happens over in the HQ site, something goes up, something goes down, it's going to get there's going to be an update sent to this site over here. And depending on the size of your environment, that may or may not be a good thing. I have seen many environments where things get really sluggish. Now, I'll be honest with you, with modern CPUs on modern hardware, we are in the 2020s, where in the 2010s, especially the early 2010s, it was frowned upon to scale EIGRP very, very wide with a single autonomous system. So the most common thing for us to do to scale EIGRP to make it work for large-scale enterprise was to use multiple autonomous systems and then distribute basic redistribution between different ASs. And it's very, very simple to do that. You would enable EIGRP on a handful of links, and then you just redistribute from one AS to the other. And because it's EIGRP, you don't have to worry about setting the metric calculation because it's EIGRP to EIGRP. So yes, you can do redistribution with inside of the protocol. The RIP you can't, but everybody else you can. So IS to IS, EIGRP, OSPF, BGP, so on and so forth. Even though theoretically speaking, BGP is a single autonomous system per box and you can't run two ASNs on the same device, you can't redistribute. It gets more interesting when you get into that, and I'll talk more about how that works down the road. But EIGRP, OSPF, and ISIS, You can run multiple instances of the protocol on the same device, and then you just have to redistribute between the two processes, and everything works out. And then you can filter at that point too if you'd like to do so. So what I'm going to go do is we're going to look at it from the remote site first. So we're going to take a look at how you can optimize. Now, this is going to be some stuff that we've already looked at, but regardless of how we cover it, the important thing here is to remember that there's scalability options with EIGRP, and they're not just limited to a single location, right? So conceptually, there's a number of things that I would do. Number one, if I'm looking at these switches right here that are running EIGRP and they don't connect to anything else, right? This is the distribution layer, and we need to make sure that if something happens at, upstream, that switch 2 and switch 1, they're the edge. There's no reason why they should ever get asked, hey, do you know where this thing is? They shouldn't. So what's the first thing that I would do on switch 1 and switch 2? I could play the Jeopardy theme song for the final question, and the answer to you, I would be looking for from you, what is the stub? That's what I would do. I would throw EIGRP stub capability on these guys right here. Also, there's a bunch of SPIs for all the VLANs that are running on this environment. What would you do in that particular case? You got it, passive interfaces. Now, what would you do in terms of, would you keep running the same autonomous system number across the board? And I know some people are going to be like, well, it depends. It does, but this isn't a design, well, it technically is kind of a design discussion, but in my experience, there's best practice. Best practice dictates that whenever you have EIGRP spanning a large geographic area, you should break it up into different autonomous systems. This way here, that if something happens over in this location, it doesn't propagate issues over here. So I'm not going to turn on the stub feature or passive interfaces right away, because we're going to play devil's advocate and say we're going to do different autonomous system numbers first. There's also the concept of summaries. So we'll see, okay, what's a summary look like in terms of its capabilities? So I'm going to actually turn the capability, I'm making a quick adjustment on switch 7 here. I'm going to clear the screen. And we're going to go ahead and get this all up and running. But the bottom line that I want to make sure you guys understand here is that when you and I are having a conversation with a customer, because most of us are going to become third-party consultants. You're going to go to work for a value-added reseller who is going to want to take advantage of your Cisco credentials, whether it's CCNA, CCNP, CCIE, and you're going to be working with a plethora of different customers with a variety of different network complexities. The bottom line here is if you're doing any type of large-scale routing, the routing that you're going to be doing is going to really depend on what is needed for the customer's environment to work. So, you and I are having a conversation with the customer, and I would say, okay, this is what you have going today. You've done an assessment, and this is what you have assessed. You're not a big fan of, from firsthand professional experience dealing with EIGRP and customer networks, of having one big autonomous system. So what you're going to suggest is, let's break it up into, and there's different levels of impact as well, and you'd have to break this down. You'd have to be like, okay, so let's talk about this real quick. There's a couple different ways that you can go about this. Number one, you can do simple summarization. You can go onto here, you can say R58 on the tunnel interface. You could simply summarize everything that's coming out of the HQ location that you just want to send RFC 1918 across the wire. So on the tunnel, you just do a summary 10/8, 172.16/15, and then, /12, and then you would do 192.168/16, and then that would, let's go ahead and take a look at that real quick. There's actually a small adjustment I need to make on switch 7 in order to get this to work, but let me go do a show run interface gig interface gig 1/1, and I'm going to take the summary off. So CCIE pro tip, if you want to remove a configuration, just copy paste it in to the line you want to adjust, and then just type it no. And then we're going to do a do show run interface gig 1/1. There it goes, perfect. Alright. So what I'm going to go do is, now that that's been taken care of, if I log into R25, for example, and I do a show IP route, I should see a 10.1.10 and a 10.1.11. And I do. They're both, we got, this eventually will age out, but we have the 10.1.10 and the 10.1.11, so perfect. So what I'm going to go ahead and do, this one eventually will age out. Might take it a couple minutes to age out. I might have it somewhere else configured as well. Actually, it looks like it's gone. Is it on switch? Where's switch 8? Switch 8 is right there. How did you get over there? Let me take a look at show run interface gig 1/1. There it is. So we're going to go ahead and remove that as well. So now switch router 25, we'll get the update. And I'm running debugs here just so we can see what this looks like. 10.1.10 and 10.1.11 now are /24, so there's no /23. Perfect. So what I'm going to go do is I am going to go over to R58, and I'm going to do just the RFC19 address space. So interface tunnel 0, and I'm going to type in IP summary address EIGRP 1, and then I'm going to type in 10.0.0.0/8, and that's going to resynchronize the tunnel. I'm going to come in here and do a 172.16.0.0/12. So basically anything 172.16, that'll resynchronize the tunnel, and then do a /16 for 192.168. And then that's all I have to do. Now, what should end up happening, hopefully, is on switch 1, we come over here, we do a show IP route, and we should get a 10/8. Let me go down to the bottom here. We should get a 10/8, which we do. We have our 10/8 subnet now coming through. We have a 172.16/12, which we do. And then we have our 192.168/16, which we do. So by having that in place, what that gives us now is summaries, right? We have our local subnets right here. We have a /24 that's more specific. Then we have our local routes. So, but if you notice, we don't have anything more specific. You notice that, right? We don't have anything more specific on switch 1. And that's the point of having that. The point of doing the summaries is to take a bunch of more specific routes and get rid of them. So if I go back over to R58 and I was to say no to this guy, it's going to resync the tunnel. Then if I go back to switch 1 and I hit the up arrow again, I'm going to get a lot more specific routes. So I'm saying don't summarize 10/8, right? So what you're going to get when you do something like this is you're going to get anything 10net is going to come through. So by simply going to R58 and putting in a summary of 10/8, you know, and doing the RFC 1918 and doing that, it's going to resynchronize the tunnel, and it's going to take all those longer matches and it's just going to get rid of them. It's going to say, you know what, we don't need them. And then switch 1 will then just have a much smaller routing table. That's a whole lot easier to work with than it is having to deal with a bunch of other subnets in there you really don't care about. And the goal is to point to a next hop saying, if you don't know where to go to router 21 or 22. Router 21, router 22 will know what to do with it. So if we do a show IP route here, same thing, right? We're not getting the full table. We're only getting what we learn over the tunnel. And that is the key thing when it comes to like doing large scale summarization, do you have to do different autonomous systems at that point? No, you don't have to, as long as you're summarizing in the correct places. Like if you're at a boundary point of two geographic areas. So if you know you've got a tunnel, and I've seen this plenty of times with large scale DMVPN deployments that I've seen and done, where if you've got hundreds of DMVPN spokes and you've got subnets going across, well, why not summarize down? And in the event that you have a scenario where you've got more of like a hub and spoke design where you don't have local internet breakout. Local internet breakout means that the local routers, in this particular case, have the ability of going out to the local internet. We haven't configured NAT yet. We haven't gone over NAT. But if you were to take a look at router 22, well, we're on router 21. This is a good example. It does have a default route. So theoretically speaking, we could do local internet breakout and just say any traffic that isn't RFC 1918 goes out to the internet. That's a possibility. Now I could take away the default route and I could just have it locally here, but not have it. There's a couple ways that you can do it. The way that I would do it is I would use a VRF. I would put this interface inside of a VRF that would be in the global table that would be used for tunnel reachability. And then what I would do is I would create a VRF, a virtual routing and forwarding table. Think of it, a VLAN is to a switch, or a VRF is to a router. So I would virtualize the router's routing table. I'd put this interface here, or in this case here, it's this router. I would put this interface into a VRF for, say, VRF internet, and I would configure a default route to R61. That would get R21 being able to talk to R58. But then what I would do in the global table is I would enable EIGRP on the tunnel, and then we would just have that. All the EIGRP routes would be in the global table, and then what I would do is go through and advertise the default route from R58 across the tunnel down to R21, and you could at that point just advertise as the default. Just say everything, send it to me. So if you wanted to centralize your routing, bring it back to an HQ. I've seen this done a lot in data centers where you've got like a colo that you've got deployed, and you've got like point-to-point connectivity between a main office and an HQ and a colo facility, and you just have all of your spoke sites route to the colo, and then the colo handles all of the servers and stuff like that, and then internet access through big honking firewalls. That gets the job done too. So there isn't one correct way to do this. There's multiple ways of doing it. But the reality of it is this. You have to know how the protocol works first before you can start making design decisions or suggestions to a customer and be like, okay, this is what I think you should do. So with that being said, now that we've done what we've done and gotten our 10/8, 172/172.16/12, and the 192.168/16, that gives us some flexibility. Now, does that control queries? It should. It really should. So if I was to go, and I'm not doing any type of query suppression here, if I was to go to, say, switch 7 and do show IP interface brief. Now, I was doing some testing before this, and I have this 172.31.100.7 loopback address created. So I'm going to go into interface loopback 100, and I'm going to shut this guy down. What that should do is it should propagate the route, and if I look on switch 1, right, I shouldn't see that. Right? Let me go turn this back on switch 7. Type in no shut. And on switch 1, now mind you, I don't have any like anything special going on. I'm just doing network advertisements. If I debug EIGRP packets, query, detail, if I look at acknowledgement detail, stuff like that, if I go back to switch 7 and I say shutdown, switch 1 gets it, and if I scroll up, it's in queuing and acknowledgement. So it doesn't specifically state. So from switch 2, it's getting some queuing acknowledgement. But we don't see anything beyond that. We don't get a query. We get an acknowledgement that we propagate, but there's no query here. So that what that means is that from 1 second, am I on switch 1? Let me options session. I had to turn off the audio bell. That drives me up a wall. Anyway, what that tells me is that because we're doing query scoping through summarization on R58, when switch 1 gets the update, yes, he's going to get the update. He's going to get an update regardless. It doesn't matter if you're doing inter-AS redistribution or what have you. He's not going to get he's not going to get the update. It'd be a different story if R22 was to get it because he's local, right? There is no summary between him. So if I was to do this on R22, for example, well, let's go to R21. We'll go interface loopback 100. IP address here will be 192.168.100.21/24. Okay. So do show run section EIGRP. So I need to go to router EIGRP 1 and type in network 192.168.100.0. Now we are going to get an update from that, right? We see the new subnet coming through. But if I was to bounce that interface, say interface loopback 100, say shutdown, we should get a query. Or not. We're not doing anything fancy on this side. So we're not doing any stub routing. So conceptually speaking, we're going to get the update that but because there's a summary northbound that encompasses the 192.168 subnet, if we were to say no IP summary address, right? We get that. And if I look back up here, so there's no summary now for the 192.168 address block. I go back to R21 and I say no shut. Give that a second. Switch 1's going to get the update. Now if I go back to R21 and say shut, do we see a queue, a query? I don't see a query. All I see is acknowledgements. And we're not doing anything on switch 1 that's stub routing. So it's kind of interesting, but now mind you, that's local to that's local, right? If I go back over here to switch 7 and I do show IP interface brief, and I say no shut for loopback 100, switch 1's going to get the update, right? I'm going to do this a little bit, go back to switch 7 and type in shutdown, and well, that's a 172 address, so that's a bad example, but I'm bouncing once a 172 subnet. So, but my point here is trying to emphasize that because of the fact that you're doing summarization, you're not going to get a query. You're going to get an acknowledgement of a route update, but you're not going to get a query. You're not going to get asked, hey, how do I do this? So let's go back to 58. And we'll go ahead and pull that out. Let me go back to 7 and say no shut. So switch 1 will get the update. So conceptually speaking, if I go to switch 7 and I type in shutdown, let me just make sure that it got it. Show IP route. Yeah, so it's getting 172.31.100. I come over here and I say shut. I'm not seeing query. I am doing a debug, so show debug. Yeah, so its packet debugging is on. So why it's not showing me the query, I'm actually kind of surprised on. But the point being here is that if you're doing any type of summarization, you're not supposed to get queries. So let me go back over to 58 and put these back in place. And put that back in place as well, so that when switch 1 does get the update, it's just an acknowledgement of the route updates. He doesn't care about anything else, and that's the key feature here. Is just tell him about the updates. Don't ask him whether or not he has a route, an alternative path to that same route. So what I'm going to do is on switch 1 and switch 2, I'm going to go to global config here and type in router EIGRP 1. I'm going to type in EIGRP stub and hit the enter key. And do the same thing on switch 2. So I'm going to go to global config, router EIGRP 1, EIGRP stub. So router 21 and 22, if I say show IP EIGRP neighbor, show IP EIGRP neighbors detail, what I'm going to get is connected summary, right? Which means their connected and summary routes are going to be allowed to propagate, but you're not going to send them queries, suppressing queries, right? Don't send a query to a stub because there's no point. So that's one of the key things to keep in the back of your mind when you're looking at large-scale design. The other thing that I'll do is on switch 1 and 2 is passive interface on all the SPIs. So what you can do, I'll show you how to do it both ways. So we'll type in passive interface VLAN, what is it, 13 something? Yeah, they're right over here. Passive interface VLAN 1315, 1316, 1318, and 1319. So what that's going to do show run section EIGRP, is it's going to prevent switch 1 and switch 2 from forming EIGRP adjacencies with themselves over their LAN facing interfaces. That's a big thing you're not going to want to have happen. You're not going to want to have your downstream trunk interfaces that have the VLANs enabled for them, for the SPIs, for the routing. You don't want those particular downstream interfaces running or forming EIGRP adjacency over them. Because if there's a problem, you're potentially going to go the wrong direction, and you don't want to have that. So your SPIs, when you do the passive interface, won't send or receive EIGRP hellos, but what they will do is it allows them to still advertise the subnet into EIGRP. So therefore EIGRP will be able to propagate it everywhere. So another way of doing this on switch 2 is, let's say you have a lot of connections. So you have a lot of SPIs, and you are just tired of dealing with the garbage of adding, every time a new SPI gets added, you have to go in and add a new passive interface command. So there's an easy way of doing this. So what you would do is it's a quick do show IP interface brief, and then I would do a, let's say we've got 100, well 100 is a little extreme. Let's say we've got 15 SPIs, so 15 different VLANs that we're routing for. What I would do is I would type in passive interface and then default by doing default, you're saying disable EIGRP on all interfaces. Then you hit the enter key, and then that takes down the adjacencies for everybody. And then what you would do is you would type in no passive interface, and then you would say gig 1/0 and 1/1. And then when you do that, it'll automatically bring the EIGRP adjacency back online. Whatever you do, don't do this when you're remote. Don't do that. Not a good thing at all. Now it's different if you've got if you're standing a switch up for the first time or something along those lines, then that's fine. If you have access directly to the switch and you want to do that, be my guest. But for the majority of them, don't ever do that, because then what you'll literally do is you're going to lock yourself out of that box, unless you have out-of-band access. So I don't recommend doing that at all. All right, so now we've done that. That's those pieces. So we've done passive interface default, we've done EIGRP, Stub on the remote site, and all that good stuff. The next one is going to be probably the most interesting, is going to be changing autonomous system numbers. So I want to do a autonomous system number per location. So we're just going to come up with random numbers. So inside of the core, EIGRP 1 will be fine. I'm going to do EIGRP 100 over the DMVPN tunnel, and then EIGRP 10 over here. So all we're going to do is we're going to all the same configuration that's working today on the remote site. So let's pretend like we're doing that. We're going to go over to switch 1 and start there. I'm going to say do undebug all, and we're not doing any more testing of queries and stuff like that. I might do one or two, but I really want to show you guys how to do the migration, because we're going to be migrating from one autonomous system to the other and how you would do that. It's a fairly straightforward process, but I'm going to walk you through it. So on switch 1, you're going to go do show run section EIGRP, and then we're going to go type in router EIGRP 10. And I'm literally going to copy all of this right here into EIGRP 10. Okay, we do the same thing on switch 2. So do show run section EIGRP, router EIGRP 10, and then we're going to do this, just like that. The next stage is to go to 21 and 22, and then show run pipe section EIGRP. We're going to router EIGRP 10, and then we're going to go ahead and copy and paste all of this into 10. Okay? Then we're going to go to 22 and do the exact same thing. Show run section EIGRP. We're going to router EIGRP 10 and copy and paste all of this into EIGRP. Okay, now that I have that up and I've got a new autonomous system number appearing with switch 1 and switch 2, which is what we want to see, so do show IP route. You're not going to notice a whole lot of anything, but you're in good shape none the least. So the next stage is to do what? Well, I want to continue standing up all my connections. So I'm going to go to router EIGRP 100, and I'm going to type in network 192.168.0.0. And then same thing on 22. So router EIGRP 100, network of 192.168.0.0. And I'm going to go to 58, do the same thing. Router EIGRP 100, network of 192.168.0.0. Now momentarily we should form a new adjacency over that, which we do. Alright, so now what we need to go back and do is on 21 and 22, I'm going to go over here. So underneath EIGRP 100, I'm going to type in redistribute EIGRP 10, and then underneath 10, I'm going to redistribute 100. And then on 22, do the same thing. So redistribute EIGRP 10, and then underneath router EIGRP 10, I'm going to redistribute EIGRP 100. Alright, so now that that's done, I'm going to go over to router 58 and do the same thing there. So I'm going to redistribute EIGRP 1, and then underneath router EIGRP 1, I'm going to redistribute EIGRP 100. So all I've done is I've done the exact same configurations. All I've done is gone through, stood up my new autonomous systems on the new routers, and then done all the pre-work. Took me, what, 5 minutes not even 5 minutes to do all that? Now that we've done all those steps, now we get to go back over to switch 1, and we're going to go ahead and type in no router EIGRP 10 or 1. So that's going to take down the adjacency for 21 and 22, right? But if I look at switch 1, and I do show IP route, it doesn't matter, because now all of my routes are external. Now a lot of stuff is missing, right? All my summarization, that's gone, because now we're dealing with a new autonomous system. I go to switch 2, do show IP route. Everything's still, for the most part, stuff is still in place, right? Some of it's still coming through, but some of it's not. So I'm going to go ahead and on this box here, I'm going to do no router EIGRP 1. Then do another do show IP route. So we have all new subnets coming through. They're back up and running, but notice now nothing goes down, right? Everything looks pretty solid. Then we're going to go over to router 21 and 22 and do show IP EIGRP neighbor. Right now we have 10, we have connectivity, 100, we have connectivity, so, but we don't have any adjacencies in 1. Do show run section EIGRP. So what I can do now is I can just go ahead and say no and router EIGRP 1. As long as everything lines up. You'd want to just verify your neighbor connectivity before you do this. We already have everything up and running in 10, so I'm just going to go ahead and say no router EIGRP 1. We don't get any synchronization on switch 1 and 2 because they already have everything learned. Same thing here. So do show IP EIGRP neighbor. Everything's looking good there. I'm going to type in no router EIGRP 1. So that's, we only have connectivity locally on AS10, and then we have a tunnel connection over. So then what I'm going to go over to do at 50, or 58 I should say, is I'm going to type in do show run section EIGRP. We don't need we do need EIGRP 1 because there's connectivity inside of EIGRP 1, but we've done redistribution there. So if I do show IP route, I should be getting EIGRP externals for the remote site connectivity, which I have. Now if I look at, say, switch 1 and I hit the up arrow, do show IP route, notice how a lot of stuff is still external, but if you also notice that my summaries are coming through, but they're weird. They're not quite right. Even though I'm getting my 10/8, I'm also getting all those longer match stuff. And that is because summarization is one of those things that's autonomous system specific. So if I want to do summarization with multiple autonomous systems, I can summarize, but I need to summarize at the boundary. So instead of me doing 58, doing the summarization of 58 and like catching every location with 3 summary addresses, now I got to go to the remote side, 21 and 22, on each of these interfaces, gig 01 and gig 00, and I got to do summaries downstream. So there's a pros and cons to doing both, right? So you have to really figure that out before you start pulling the trigger on doing things. So what I'm going to go do now is on router 21, I'm going to go to interface range gig 0/0 through 1 and type in IP summary address EIGRP 10, and I'm going to specify 10.0.0.0/8. Now if I go, just by doing that alone, let me go back to switch 1, we get a resync, right? Now if I hit the up arrow and do show IP route, well, we're going to learn a lot of stuff from router 22 because we've only made the change in router 21. right? So on switch 1, we should still be getting a lot of longer matches from 22, but not 21, right? So everything's coming through. So you have to take it a step further and go to 22 and type in interface range gig 0/0 through 1, IP summary address EIGRP 10 10.0.0.0/8, right? They're going to resynchronize. Now switch 1 should have a minimal routing table. Now it's a lot smaller, right? So this is one of those situations where you have to look at the trade-offs. Where do I summarize versus where do I do different autonomous systems, things like that. So in this particular case, it might make more sense to do it upstream, where you don't have to worry about summaries in 17 different places. But at least you can do it wherever you want. There's no hierarchy in EIGRP. You make your own. So if we did a hierarchy, we could say that this is a boundary point to our hierarchy, and then we do another one up here. We could do it even further to the core, where in the reality of it is it makes more sense sometimes to just do one big autonomous system and go a different route with it. So it really depends on what you want to do. Again, the idea here from this particular set of examples isn't to say one way is better than the other. They both have their own use cases depending on the scenario. So I'm trying to do my best showing you guys how EIGRP can be scaled and how propagation can work. So if you have any issues, you can just demo these out yourselves in a home lab like I've done multiple times and see exactly how they work. So that's, at the end of the day, that's really what it is. It's like how many different tools are in your tool bag to where if you're presented a situation that you can just reach into your tool bag and go, which one do I want to grab? Okay, this one looks good. And I think we should do this. But you really only know that if you spent the time labbing this stuff up. And you know the outcome if you implement a particular solution, you know what that solution is going to look like. So there's a question, could you use that same concept to do traffic engineering? You could. You absolutely could. So in most cases, let's say I had a DMVPN deployment where I've got internet and MPLS VPN connectivity on these two boxes. If I was to do an internet-based DMVPN tunnel back to 58 and an MPLS VPN tunnel back to 58, I could set a summary, a shorter match summary over the internet, and then a longer match summary over, or just let the normal longer match routes propagate to the remote side. I could do like a /20 to try to concatenate it as much as I can. But the idea would be the longer matches win, so the traffic would go via MPLS for any time it needs to, and if MPLS is having a problem, you just go revert back over to your internet tunnel. We don't have MPLS stood up at the moment, but when we do get it stood up, that'll be one of the things we're going to talk about. That's how you can do traffic engineering with longest match routing. So that's pretty much it. That's what I wanted you guys to see in this particular video, how different autonomous system numbers can affect your scale, your design, your implementation, all that type of stuff. Because at the end of the day, design is subjective. It varies widely. In your opinion, I might want to do something one way, but Mike, Tom, and Bob might want to do EIGRP a different way. And you have to explain the pros and cons. But if you've never actually done the demo or know what the outcome is going to be, I want us to keep saying action. The result of your testing, then you're going to be relying on your opinion, and that's one of those things where it's important to demo things out. I'm a big proponent on test, lab. So, it's even though I've been doing this stuff for basically 15 years, comes a point in time where I'm like, well, I'm going to demo this out anyway. I'm going to test it out in a lab, see what happens. Because I'm pretty sure I know what's going to end up happening, but I want to make sure I know what's going to happen. So I never go into any type of scenario half-cocked if I can avoid it. So hopefully that makes sense for you guys, and it's one of those things where you can look at it and be like, okay, that made a lot of sense. You know, you got query scoping, you got the EIGRP stub, you got your summarization, you got different autonomous system numbers. So the only thing that I really haven't shown you guys yet on the blueprint for EIGRP is going to be league maps with summary routes, and I am going to talk about that once we get a little further along. Now, I was going to do that in this video, but I decided not to, because what I want to do is stand up MPLS, and then once MPLS is stood up and we can do DMBPN over MPLS, then we'll take a look at doing leak maps on stubs, so where you can leak more specific routes outbound, and then do the same thing with leak map with summary. So if you need a specific prefix to go out a particular direction or what have you, you can unsuppress a specific /24 or whatever subnet and have the traffic go that route. And all you're doing when you're doing leak mapping is you're unsuppressing longer match routes to take advantage of longest match routing. That's all you're doing. So we'll talk more about that in detail when we get into, once we get MPLS stood up. But for right now, that is pretty much everything for EIGRP. If you guys have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you awesome people in the next video.